try not to make silly mistakes. Today I'm really tired. I stayed up to watch the hockey game. All for nothing. I stayed up. Yes. I know. I go to bed at 9. Sorry, people at home. Okay, so I make mistakes. So I'll try not to make mistakes today because I get tired. All right. Now, solving quadratic equations or for linear equations, right? We isolate x. Pretty simple. We did that in grade 8 and grade 9, right? That was fun. That was when life was simple. Those were good times in life. Okay, so moving on. Solving quadratic equations. So Tyler likes to always, this is his go-to. Negative, you guys know the song? Right, like x, which one? X equals negative b plus or minus the square root of b squared. Quadratic formula. Yeah, those are both good. But you could also sing to Pop Goes the Weasel, as I was just demonstrating. X equals negative b plus or minus the square root. Oh, sorry. Okay, so, okay. Well, I believe this is on your formula sheet. It's kind of something in calculus you kind of should just know it. And that's where the song is awesome. No, because you're using scientific calculators, so no programming it into your calculator. Now, quadratic formula, we only use that technically when we can't factor, right? Some of you like to use it even when you can factor. Technically, you can, right, when you're looking for your zeros. But you really need to be able to factor in calculus. It's just a given. It's just an assumed thing. You have to be able to do that. It's so foundational. It's like being able to multiply and knowing your times tables. Just the way it is. Gotta know it. So we always isolate, when we have a square, x squared, right, we want to get one side equal to 0. We factor. If we can't factor, quadratic formula. This is all familiar. You spent like 2 units on it, right, in grade 11? Yeah, like 2 long ones. So let's look at an example. 2x squared minus 24 equals x squared plus 10x. So I see an x squared, so we want to get everything to one side. So which side do you want to move it to, left or right? The left, okay. Now, we've got skills, right? We can move more than one thing at a time because we smart. So let's bring over the x squared and the minus 10x all in one. In fact, you don't even have to write that down. If you can just move it and write it the next step, that's great. 2x squared minus x squared. X squared. Then we have a minus 10x minus 24. Now we're going to try to factor. We always check first. Is there a GCF? Common mistake is we forget about that guy. Is there one? Nope. What kind of trinomial is this dude? Simple. So, 2 numbers that multiply to negative 24, add to negative 10. Now let's talk about the product. If you're multiplying 2 numbers that multiply to a negative, Greg, if you have 2 numbers that multiply to a negative, what do we know? Oh, Greg. Oh, the other Greg. Hey, sorry, there's 2. Thank you, Greg. Okay, one is negative, one's positive. Is the larger number going to be negative or positive? Negative, because we're adding to a negative. So the larger number is negative. Negative 12 and positive 2. So what's our solution? Negative 2 and 12. So we figure, okay, if a times b equals 0, then either a equals 0 or b equals 0. Right? So what x value would make this 0? A positive 12. What x value would make that 0? A negative 2. Life's good? All right, moving on. Can you solve this one on your own? Is it because I'm going to record it? Oh. Too much writing. All right. Okay. So I like to keep x squared positive. So did you bring over the x and the 5? Okay. Now, you want to, it looks like a complex trinomial. So we have to check, is there 2 numbers that multiply to negative 10 and add to negative 1? No, it's not possible to factor. So when it's not factorable, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Isn't that better than your song?
No.
Hey, your song is morbid. Someone dies in it. Seriously, the guy gets stabbed in the head. Okay, I like that it is tombstone. Okay, yes. Yeah, maybe we should. Maybe we should. Okay, let's finish this question, and then we'll review the song, because Mr. Boer has not heard it, and you might appreciate it. Okay, well, what's our A value? What's our B value? What's our C?
A is
2, B is -1, C is -5. Okay, so B, negative B actually is going to turn out to be negative -1 is going to be a positive 1, plus or minus the square root of -1 squared minus 4 times 2 times -5 all over 2 times 2. Okay, the inside, let's simplify. So we get 1, and then what's -4 times 2 times -5? Positive 40, so 1 plus 40? 41, all over 4. So there's our solution. And it's always better to leave as an exact value unless otherwise stated. Okay? All right, so you want to see the song. People at home, do you think they want to hear it?
Yeah, they do.
Okay. Okay. Only because you just pulled my leg. Is that the right thing? I think it's under videos.
Oh, not this.
Okay, quadratic. There's 2. Okay, can I show you mine?
Sure.
Okay, I have to turn the sound on. I think so.
The quadratic formula 1 is ours, 2 is yours.
Okay. Have you heard it before? You have to sing along. Minus the square root of b squared minus 4ac all over 2a. It's a little delayed. Equals -b plus or minus. Okay, it totally works. Okay, whatever. Some people were a little offended by the other version, but I will show it to you. The Lego one sucks. Yeah.
He said, sir, please help me. I don't understand, and I've been having trouble. This problem's all my fears. So I took out my notebook and I wiped away his tears with the quadratic formula. Quadratic formula. Quadratic formula. The quadratic formula. And it's -b plus or minus the square root of b squared minus 4ac over 2a, over 2a, over 2a. Although I couldn't factor it, I attacked the equation fast. Did I plug in the coefficients? Yep, you bet your ass me if I could explain it. This problem's down the drain. That's exactly when he stuck a knife into my brain. I exclaimed, why did you do this? Do you even care? Didn't I just help you? Didn't I complete your square? No, actually, I used the quadratic formula. Quadratic formula. Quadratic formula. Quadratic formula. And it's -b plus or minus the square root of b squared minus 4ac over 2a, over 2a, over 2a. Now my life is over. I've seen all that I can see. Quadratics, cubics, quintics, quartics got the best of me. But as I lay here dying, a strange peace settles over me, knowing that upon my tombstone carved for all the world to see will be the quadratic formula.
Enough of the shenanigans. Oops. Moving on. All right, radicals. When we are solving equations with radicals, we need to isolate the radical so that we can square both sides or cube both sides if it's a cubic root. So, looking at this example, what do we have to do first? Subtract 3. We have to isolate the radical. Ooh. My sound is not very good. Is that better? Yeah, it's much better. Thank you. Okay, root x plus 9 equals x minus 3. Now what can we do that are radicals by itself? Square both sides. What do we have to what's going to happen here? Try not to rush. Cancel, so we're left with x plus 9 equals, what do we have to remember here? FOIL. Did you learn the shortcut for perfect squares? No. No? Okay, well this would be x squared. The middle term, we just multiply these together and double it. Yeah, so minus 6x. And then the last negative 3 times negative 3, square that, plus 9. So we just, right, because you're going to get a negative 3x and a negative 3x, you double it, gives you negative 6x. Right? Okay, quadratic, so what do we have to do? Everything to one side. Ooh, this is exciting. X squared minus 7x. The 9's cancel. What do we do next? Take the x out. Life is wonderful and it looks so pretty. And so our solution, 0 and 7. Are we done here with radicals? What do we have to do? Sub it in and check, because sometimes we have something called, does anyone remember the name? The values we reject in radicals? There's something roots. Extraneous roots. So we have to check for extraneous roots. So we have to do a check for both of them when we are dealing with radicals. Why are they extraneous? Well, extraneous because we can't take the square root of a negative. So 0 plus 9 plus 3 have to equal 0. Is that true? Root 3 plus 3 is going to equal 0? No. Oops. Root 9 plus 3. Okay, what's root 9? 3 plus 3? Not equal to 0. So guess what x equals 0 is? Extraneous root. Extraneous, so we check with 7. So we go back to the original root of 7 plus 9. Actually, I should be using the root plus 3 equals 7. What's 7 plus 9? 16, root 16. 4 plus 3, 7 equals 7. Woohoo! Yay! So that one is our solution. X is equal to 7. Life's good. I don't know why I keep saying life is good. Just having a good day, even though the Oilers lost. All right, next page. Rational expressions. Solving rational expressions. Okay. Yep. Ready to do this one? So we identify the MPVs. Convert both sides to lowest common denominator. Equate the numerators. You might have solved it a little bit different, but we'll go through it. Okay, so what can we do here before we get started? Okay, sometimes in order to do that, we have to factor, right? Sometimes. So is there anything we can factor here? X squared minus 1. Okay, I'm going to show you the way that Mr. Trimble showed you. Oh, what was I doing here? See, this is what happens when you're tired, folks. Go to bed early. Okay, so now can we state our MPVs? X can't be equal to plus or minus 1. So in Math 20-1, you identified the LCD, right? Lowest common denominator. That. And then what did you do? Math 20-1. You multiplied. Did you not multiply everything by the LCD to cancel out the denominators? Is that how you solved it? Lowest, well, that's what make a common denominator. Or we could just go ahead and make a common denominator to start. Yeah, let's do that. Okay, so what would be our LCD? What would make our common denominator? What would it be? X plus 1 times x minus 1. So what are we missing in the beginning? An x minus 1. So let's go like that. What are we missing here? X plus 1. And are we missing anything here? No. So now that all our denominators are the same, we can just equate the numerators. Is that what you did, or did you just combine these first? Okay, so if you have, now that we have a common denominator, let's just simplify this side. I think that's what you guys would do. It's tough because there's different ways to teach this. We have 3 times x minus 1 minus 2 times x plus 1 all over. Okay, so now we have it all over, everything's over one common denominator. So if I really simplify this, if you had, say, 3 over 7 equals x over 7, what can you say? X is equal to 3. As long as our denominators are the same, then we can, and we know the two fractions are equal, then our numerators are also the same, because there's an equal sign in between. So now, what can we say here? Now we have the same denominator on both sides. We can just equate our numerators. Are you getting what I'm saying, Greg? No?
Oh, yeah. That's just what I was going to say.
Really? Honestly? Be honest, okay? I want to be clear. I want to be clear, right? So because this is an equality statement, if this equals this, our denominators are equal, then what can we say about our numerators? They are equal. Okay, good. So 3, I don't know if you want to go straight to expanding this or not, equals 1. So you could have actually even jumped from here to here if you want. Once we have a common denominator, we can equate our numerators. Okay, simplifying this, 3x minus 3 minus 2x, minus 2, bring in the negative 2, equals 1. 3x minus 2x, so x minus 5 equals 1, and then add 5, x is 6. We double check our MPVs. Was that an MPV? No. So is that our solution? Yeah. You can plug it into the original if you want to check. Okay. Not so bad. All right. I want to go through this example. Yeah, let's do this one. What about a cubic? I know you haven't learned about cubics just yet. You're going to learn about them this year in 30-1. Okay, and how to factor cubics. But I'm going to take you through this one anyways. Okay, so same idea as a quadratic. Everything needs to be on one side. So let's move everything to make x cubed positive. We have x cubed, and then plus 4x squared minus 9x minus 36. Okay? Now, one strategy we use when you have 4 terms. Remember in Math 10, what strategy we use when we have 4 terms? Grouping. We group the first 2, we group the second. This doesn't always work, but it sometimes does. So let's try it. What can we factor out of the first 2? x squared, and we're left with x plus 4. Can we factor out of these two? Negative 9, x plus 4. So it worked this time. So what's left? Okay, and difference of squares. And our solution is x is equal to, that's a lot of writing, negative 4 and plus or minus 3. Cool? Can we skip example 3? Yeah? Just factoring out of x and then using quadratic formula again. So let's go to 4. Can you solve this one on your own? Give this a shot. Factor 4, 3, 6, and 2. Okay. So if you got that far, great. Can you stop there with radicals? No, we have to check with a radical. If you get in the habit of always checking your answer, then you might not make that mistake. So we plug it into the original. Four minus 3 is 1, root 1 is 1, and 2 does not equal 0. So we can say, we can reject x equals 2, because when we check it, why does it give you an extraneous? Because the reason you're squaring both sides, and this is a positive root, when you square both sides, it could be plus or minus, right? So this is not the same thing as this. This has one solution, this has two. So when we do that, we create an equation where there's two solutions, but there's really only one solution here, because so it gives us plus or minus, basically, plus or minus 3. And so one of them is that negative value, that give a negative, but we can't actually, we don't have a negative right in front of here. It's not plus or minus here. That's why. Okay, so check x equals 6. That's probably going to work. 6 minus 2, so 12 minus 3 is 9, which is 3 plus 1. 4 equals 4. So that's our solution. All right. Yeah, this is your homework today. It's mostly I'll truly review today. And then we're really going to get into some new stuff tomorrow. Okay, last guy. Did you want to try them on your own again? So give this a shot, and then we'll go over it. Do you want me to wait a moment?
No.
I'm sorry. No, I can wait. You can keep working. Just ignore me. Yeah. Okay. So I notice we can factor the denominator over here. Okay, so we want to get a common denominator. What's missing from this guy? X plus 4. So we're going to multiply top and bottom by x plus 4. What's missing from this guy? An x. So we can actually put this right now all over that common denominator, if you'd like. Now, thank you. See? if your denominators were different at this point, so if you get a common denominator, combine these guys, right? You can cross multiply. Multiply that up here and this up here. That's one way to solve it. Okay, so here our denominators are equal, so we can go straight to letting our numerators equal. Because we have one fraction equals another, we have the same base. So this is equal to that. That is such a question. Okay, so foiling this out, you get 2x squared plus 8 minus 1. It's going to be 7 and minus 4. So you may have to write that all out. And then a minus x squared minus x equals 5x plus 8. So I'm going straight to letting my numerators equal. Because the bases are the same, this equals that. Because the denominators are the same. That's only because they have the same denominators. All right, combining like terms, you have an x squared here, a 6x minus 4. Question? No? Okay. Let me know if I make a mistake. So we want one side equal to 0. So you should have x squared. What did I forget to do in the beginning? NPVs, Miss Johnson. What can x be? 0. As long as you remember at some point. And that's, yeah, 0 and negative 4. That's it. Yeah. Just the denominators. Okay, factoring this, what multiplies to negative 12 and adds to 1? A negative 3 and a positive 4. So we have x equals 3 and negative 4, but it can't equal negative 4, therefore our solution is x equals 3. And if you want to check it, you can just sub in x equals 3, and left side should equal right side. Alrighty, was that an okay lesson today? Yeah. Total review. All stuff you've seen before. Okay, so the homework, if you all want to grab out those homework books. I'm sorry.
No, I'm just like, I feel like I missed something. I feel like you're doing it in a step or something. Yeah. You like I got the same thing. It took you 5 times.
This takes practice. The more you do it, the faster you get. Like anything in life. Okay, so your homework, the ones that it's on the website. If you've already seen it, great. But otherwise, are you ready to circle? Okay. Greg, you ready to circle? We're on lesson 4, right? Okay. Okay, numbers 3, 6, 7, 9, 11, 13, 19, and that's it. Okay, you can do more. This is the minimum for this lesson. Okay, you're welcome to try more. The ones with the stars are like harder. Yeah, challenge questions. No, so the only ones, and I can just, if you want to bring it in, I can check it over. The only ones on the website are the ones that are circled, that you circle, these ones. Okay, so they're right there.